Hello and welcome to my YouTube channel. This is Dramani Online Mathematics. If you know you have not subscribed, subscribe, share to your colleagues. Okay, we are going to look at wave equation. For wave equation, it is always given as UTT equals C squared UXX, where this C squared is a wave speed. Is that okay? Good. Now, let's just move straight to the point and look at the question under the wave equation. How do we solve it? The approach of the wave equation is just the same as the heat equation, just that the wave equation here you differentiate it 2 times, here to 2 times, but the heat was just 1, then 2. I hope that is okay. Good. So let's look at this question. Solve the wave equation. It is given to you. So here our c square is 9. Please don't go and take square root of 9. It's c square, which is 9. Is that okay? And they have given us the conditions. Now this is a boundary condition, and this is the initial condition. For the initial condition, you see they have given a further explanation to it. So the f at x is given as this. Is that okay? So let's see how we go about it. Okay, so let's start. First, we say that we set this u of xt to be equals to x of x, t of t, right? Is that okay? Also, the equation given to us, which is utt, is equals to 9uxx. So it means that we need to differentiate this one 2 times in terms of t, this one 2 times in terms of what? X. But before you do that, you need to set our boundary conditions. The boundary conditions, already I've been doing this thing, so you know it already. It is given to us here. So it will be 0 and what? Pi. The heat equation, I did that. So the boundary condition is going to be x at 0 is equals to 0. X at pi is equals to 0 when you set it. Now, if you don't know how this thing is done, move to the heat equation. Check the video, it is there. Now, after this one, we need to differentiate this 2 times. So let's do that. UTT is going to give us x t prime prime. Then uxx is going to give us x prime prime t. Then after that, we come and substitute here. So my utt is x t prime prime is equals 9. Uxx is what? X prime prime t. Is that okay? So here we try to do the simple division that we do. So what I'm going to get here is x prime prime over x equals t prime prime over 9t. And you say this should be equals to lambda. Now you realize that here I'm putting the 9 at where the t is, okay? Normally, that's what I like doing. You can also put it at where the x is. Now, after doing this, you take this one, you take equate it to this, you take equate it to this. So when you do that, have x prime prime minus lambda x is equals to 0. Then this one too is going to give you t prime prime minus 9 lambda x is also equals to 0. You take this one alone, equate it to this one alone, equate to this, you get these two. After getting these two, there is a condition, boundary condition given. We are saying that when capital X is 0, this one, the small x2 is 0. Now here, when we're dealing with the heat, I say it's the same thing. I first consider this one first. This one, you only consider the third case. So the three cases, let's look at them. Where lambda is equals to 0, where lambda is greater than 0, and when lambda is less than 0. These are the three cases. So the first case is when lambda is equals to 0. So we have not even getting to this place, and I wanted to use it. So when lambda is equals to 0, if I put 0 here, this one will go to 0, leaving x prime prime equals 0. So you integrate this one. So after doing the integration, you're going to have ax plus what? B. This, I've done it in the previous video, so I know if you have followed it very well, you'll be able to do this. Now, we are now coming to use this. When small x is 0, capital X is also 0. So capital X is 0 equals a multiplied by 0 plus b. It tells you that my b is equals to 0. So we're done with that one. So b is 0. Now when capital X is 0, small x is lambda, sorry, pi. So here is going to be 0 equals a pi. Remember, b is already 0. So here too, a will be equals to what? 0. Because if you divide both sides by pi, you have a to be 0. So you say that since b is 0, a is 0, this one will yield what? Trivial solution. So once you get a trivial solution, you move on to case 2. I've told you that even if you do this one and the first one, you get non-trivial solution, you have to do all the cases. Okay. Now, second one. When lambda is greater than 0, you let lambda to be equals to p squared, and I've explained this. So if that is the case, it means that when I come here, wherever I see lambda, I should put p squared there, x equals 0. This is second order. So here, if I want to solve it, to be r squared minus what? P squared equals 0. So my r will be equals to plus or minus what? P. If you solve for r, you get this. Good. So you're going to write solution for this. Small time, I will not be dividing it again. So the solution is going to be x of x is equals to aepx plus b e negative px. This is the solution. Again, let's substitute this. Small x is 0, capital X is 0. So let's do the substitution. We are going to have 0 equals a e to the power 0. This will give you 1. Here 2 will give you 1, so this one will give you this. This tells me that my b will be equals to negative what? A. Or a is equals to negative what? B. Now let's also check for the pi on. Capital X is 0, so 0 equals a e to the power p pi plus b e to the power negative p pi. But this b is the same as negative a, so we can represent it like that. So we have a e to the power p pi. So instead of b, let's put negative a there. So negative a e negative p pi, and this is equals to 0. A and a is common, so I can factorize it out, leaving e p pi minus e negative p pi, and this is equals to 0. Is that okay? Now here, you and I know that there's no way that the exponential function can be 0. So the only thing that can be 0 here is a equals 0. But this, which is e p pi minus e negative p pi, can never be equals to what? 0. Is that okay? So here too, if a is 0, b will also be 0. So since a and b are 0, we also yield what? Trivial solution. Is that okay? Yes. So that one is also done. So we move to case number 3. So case 3, you say that lambda is less than 0. So you say that let lambda to equals negative p squared. So that one, what is it? That one is going to give us, so here become positive. So we are going to have x prime prime plus p squared x equals 0. So I have r squared plus p squared equals to 0. This means that my r will be what? Plus or minus pi, because we get a complex. And you know how to write solution for a complex. That one is going to be a cos px, right, plus b sine px. So that's the solution that we write when it is complex. Now, again, we visit to this place. Small x is 0, capital X is 0. Small x is pi, capital X is 0. So let's take when x is 0, capital X is also 0. So it means this place will be 0. If I put 0 here, it will be cos 0 is 1, so here will be a. If I put 0 here, it will be sine 0 is 0. Bit times 0 is 0, so everything will go, it means a is 0. Now, what of the pi? So we are going to have 0 equals, already a is 0. So if I put 0 here, everything here goes to 0. Leaving b sine p pi. Okay. But we are saying that if you also make, you know that for the obvious reasons, sine p pi will always be 0. But b can also be 0. But here, one of them should be 0. So you should take one. You should take the sine p pi so that the b will not go to 0. Because since this b goes to 0 and a is 0, you get another trivial solution. That means the problem cannot be solved. So in this case, we say that b is not equals to 0, but sine p pi is equals to 0. And I've explained to you, if you put p to be 1, you get sine pi is 0. P to be 48, sine 48 pi is also what? 0. So that is very, very what? Nice thing to done. So here we say that we are going to replace this p by what? N. So what you normally do here is that, let me clean this side. So what you normally do here is that you say that you let p pi to be equal to n pi. Okay. Always you will let that, so that you represent the p by what? N. If here is 2p pi, or just 2p, or 3p, 4p, you will see select 4p to be equals to n pi. They make p the subject. So here it means that our p will be equals to n. So what you are going to do here is that when we come back to this place, you are going to substitute here. When you come back to this place, this p should be represented by what? N. So it means that our final distance, because of the n, you bring this small subscript n there. A is 0, so everything here goes to 0. B is not equal to 0, so I can write my b. B subscript n sine p is n, so nx. So this becomes our x. So let's write it here. In fact, I'll be needing it, so let me write it down here. My xn, which in terms of x is equals bn sine nx. Is that okay? So this is what you're going to get. So I'll use it later. Let me clean everything, because what I'm going to do will be very long. Now look, the next one is, let me the t1, which is t prime prime minus 9 lambda t equals 0. And I'm saying that for this one, you only consider case number 3, case 3. What is case 3? Case 3 is saying that lambda is less than 0. So it means we let our p, our lambda to be equals to negative p squared. In some books, you see that straight away here they will change this p squared to what? Should also be equals to negative n squared, where n is equals to 1, 2, 3 to infinity. Okay, because for the x side we use n, you are using n for that. So straight away, let's replace the p instead of working with the p. And then after that, we come and substitute with the n. Let's start working with the n straight away so that it will be easy for us. So I'm going to have n prime prime, sorry, t prime prime minus. Okay, so the n is already negative, so here will be plus n squared t equals 0. Is that okay? So here is going to give us, this is also second order. You see, the heat was first order. That's why we solve it differently. But this is second order, so it's the same. R squared plus 9n squared equals 0. And that my R will be equals to, if you send this one, then it will become plus or minus 3. Sorry, this is supposed to be n squared. 3n squared. So the n, the square will not come again, right? If you are confused, send this one to this place, become negative, take square root. Okay, so there will be I. Thank you. So here will be I. So you are going to have I equals plus or minus 3n I. This is complex. So let's write the solution for the complex. The solution for the complex, this is t. In terms of t, is going to be a cos. This one will be what? 3n x, okay, plus b sine 3nx. So this is what you're going to get. You're going to have something like this. So if you have this, you are good to go. Is that okay? Now, let's, for this one, you know that you don't have any boundary condition to substitute. Okay, you know that here is supposed to be t. You see, we are doing it with respect to t, not x. So we just leave it as it is. So now, what we are looking for is this equals to x of x, t of t. By x of x, we had it here. So you are going to put it there. So my u, x of t equals x of x, we had b n sine nx. And it is multiplying the whole of a cos 3nt plus b sine 3nt. Then you close the brackets. Okay. So this is what you're going to get. Let's multiply through and see what we are going to have. U will be equals to b. So you see this one and this one, they are all, let me be putting n and b. They are all constant. So if I multiply this constant by this constant, it will be b n a n, which is a constant. So instead of that, I can replace that one by just a n. So that I have something like this, a n. Then you have cos 3nt sine nx. So this and this, you get something like this. Plus, there is a constant here meeting another constant. So let me replace that one by bn. Now, this and this, you are going to have sine 3nt sine nx. So this is what you are going to have. Is that okay? But you see this n, you said that it's ranging from 1 to infinity. So you can write this one in the summation form. So u will be equals to summation n equals 1 to infinity. A n cos 3nt sine nx, then plus bn sine 3nt sine nx. So this becomes the general solution. Okay, but we need to find the an and also find what bn so that we get a particular solution. So that's what we are going to do for now. So first we need to find the an. But before you find the an, we need to introduce the initial condition. This was the boundary condition. We have already defined for the boundary condition. So we are moving to the initial condition. I've told you that for you to identify the initial condition. The boundary condition, the t are not always 0, but for the initial condition, the t is always given as 0 or 1 or any number at all. But here the t remain constant. Good. So let's use this one. This is the initial condition. Let me explain this initial condition for you. This is u of x0 equals f at x. Where is the f at x? This is the f at x. The f at x is equals to x or pi minus x. Is that okay? And it has been defined for the limit. This is the lower limit, this is the upper limit here. This is the lower limit, this is the upper limit. And the second one, u of t, means that a use as with t, it means that you have to differentiate this one with respect to t. Okay? That is, you take the whole of this, you differentiate it with respect to what t. Very good. So let me write this one somewhere here so that I won't forget. Even let me write the t of t down here. That one I had an cos 3nt plus bn sine 3nt. Then my u itself, I'm having n equals 1 to infinity an cos 3nt sine nx plus bn sine 3nt sine nx. So this is what we have. Okay, good. Now let me clean this side. Okay, so for this, let's apply the initial condition. The first initial condition is given as this: u of x comma 0 equals f at x. Okay, now the f at x2 is in twofold, this and that. So let's substitute first. The meaning of this is that the u is equals to f at x. So first I'm going to consider when f at x equals what? X. When f at x equals what? X. And the condition is 0 pi on 2. I'm going to use this one first. Their limits. I'm going to use this one first. So I'm going to have x equals, this x represents the u, okay, equals to the summation as n goes to 1 to infinity an. Now let's look at something here. Here they are saying that t is 0, x is x. So if t is 0, if I put 0 here, that will be cos 0, which is 1, leaving an sine nx. So here I'm going to have sine an sine nx. Okay. Then when I come to plus, when I come to this place, if I put t0 here, so sine 0 will be 0. So everything here goes to 0. So this is what I will be having. And this is Fourier sine, so I have to integrate it accordingly. So we find an. We are just looking for an. Fourier sine, the formula is 2 over L. But here, our L will be pi on 2. So you see the pi over 2. These two multiply the 2 top here. So we can write this one as 4 over pi, moving from 0 to pi on 2. The function f at x is x here. multiply by sine nx dx. So this is what we are going to integrate. So let's see how we can integrate this one. X, sorry, u, then v. This will be my x, and here will be my sine nx. Because s can be what, terminated. So look at the number of times I'm going to differentiate this. 1, 0, 2 times. So I have to integrate this one two times. So this first one is going to give me negative 1 over n cos nx, right? Second one is also going to give me negative 1 over n squared sine nx. So now this one will go here. This one goes here, plus minus. So you see how I'm going to write this. For this one, I am not going to ignore anything because of the limit. It's 0 to pi on 2. It's not just pi. If there was pi, sine will be 0. So here is going to be x multiplied by this, which is going to give us negative x over n, right? Cos n. 1 multiplied by this. And again, that gives you positive. So plus 1 over n squared sine nx. So this is what we have. Okay, good. Let me clean it. So now my an is equals to this one. The limit is from 0 to pi on 2. Let me write it well. It is this negative x over n cos nx plus 1 over n squared sine nx. Limit from 0 to pi on 2. So let's do the substitution. First, pi on 2 first, okay? And remember there's 4 over pi here. There's 4 over pi here, which is multiplying through everything. So I'm going to have 4 over pi. Now I'm going to put the pi over 2 here. Remember, if I put pi over 2, this place is going to be negative pi over 2n, right? Here is going to be cos, brackets open, n pi over 2 plus 1 over n squared sine n pi over 2. Now look at what is going to happen. Minus the lower limit. If I put 0 here, 0 multiplied by the cos, everything here goes to 0. Sine 0 2 is 0. So here I don't need to bring that. So this is what I'm going to have. So my final distance is going to be an is equals to 4. So let me multiply the 4 through. I want the negative to go to this side, so I'm bringing this one first. So 4 times this is going to give you 4 over pi n squared sine n pi over 2, something like this, minus 2 going to 4 2 times, right? So I have 2 here. Pi will cancel this pi, so I have n here, cos n pi over 2. So this becomes the final answer for what? An for this particular limit. So when you finish with that, you then come to this one. Is that okay? So let me clean the top one. All that we are doing, when we finish, we are going to put it here. Then you also look for the bn. That one is very, very important. Let me clean top here. I want to write something here. You are done using the question soon. So let me write the an here. An is equals to 4 over n pi squared sine n pi over 2 minus 2 over n cos n pi over 2. So this is for our a. So I can clean all this one. Okay, now that we are done with the this side, let's move to this one. You know the definition already. Definition was this: u of x comma 0 is equals to f at x. That was the definition, and the f at x is this and that. Okay, already you have done using the x. Let's use this one. So if you are using that one, then to substitute it means that here it will be the same thing. Wherever I see x is x, wherever I see 0 is 0. So it's the same thing. It means that if I put 0 here, everything here will go to 0. And here it will go to 1. So I'll get the same thing. I'm going to have something like this. Just like what I had for the first one, which was an sine nx, like this, okay? But the only thing that changes here is that here we are not using the f of x is now giving us pi minus x, and it's now using this limit. Is that okay? So you are going to use that one to see the an again. So u is the same as the f of x, which is giving us pi minus x, okay? Is equals to n equals 1 to infinity an sine nx. So now you need to find an. So for you to find an is equals to, this is still Fourier sine. So I'm using 2 over L, but here my L will be the upper limit, which is pi, starting from pi on 2 to pi, right? I hope you're okay with this one. F at x, which is pi minus x, multiplied by sine nx dx. So I'm going to integrate this one. So you see how the integration is going to look like. So here is my u, here is my v. So I have pi minus x, I have sine nx, right? Pi. So pi is what? A constant. So if you differentiate a constant, you get 0. This one will give you -1, then you go to 0. Then here too, I'm going to have -1 over n cos nx. Remember here, we are integrating. Under the v, we integrate. That's why when you integrate sine, it gives you negative cos. Now here we give you -1 over n squared sine nx. So this goes with it, this goes with this, plus minus. Is that okay? So this is what you're going to have. So let's see what we have for an. 2 over pi minus x is multiplied -1 over n. So this negative is affecting this. If I multiply the -2, the x will become positive, right? So I'm going to have x minus pi, all divided by what? N cos nx. Is that okay? Then -1. How many negative do you have here? 1, 2, 3. So at the end, we get negative answer. So here is going to give us 1 over n squared sine nx. So this is going to give us negative, it will be negative 1 over n squared sine nx. That's what you are going to have. The distance is pi over 2 pi. So this is what you have. Let me clean here. Now that we have this, see, pi over 2 to pi. Let's substitute the pi here. We know that if I put pi here, it will be -1 to the power n. If I put pi here, this one will go to 0. Even here, let's check something here. There's x here. So if I put pi here, it will be pi minus pi, which will be 0. So everything here will be 0. If I put pi here, everything here will be 0. So that one is done. So let's move on. Minus the lower limits. So let me bring the minus outside. -2 over pi. Minus the lower limit. The upper limit, everything will give us 0. So minus the lower limit. So the lower limits, if I put pi here, I'm going to have pi over 2 minus pi, right? All divided by n. But let me solve this one. This and this will give me negative pi over 2, right? So if I put pi here, I'm going to have negative pi over 2, which is the same as negative pi over 2n. Can bring the 2 at where the n is. Now if I put pi here, I'm going to have cos n pi over 2. Sorry, pi over 2, not just pi. X is pi over 2. That's why I put pi over 2 here. Then minus 1 over n squared sine n pi over 2. This is what you are going to have. Okay. Remember, the negative is affecting everything. So if I multiply through by the negative 2 over pi, I have an. This negative is coming from the fact that we are substituting the lower limit. So the upper limit minus the lower limit. The upper limit gave us 0. So now negative times this will be positive. This 2 will cancel this 2. This pi will cancel this one. So it will have 1 over n. Is that okay? Cos n pi over 2. Now this negative coming here to cancel, leaving positive. Here nothing can cancel this. So we have 2 over pi n squared sine n pi over 2. So this is what we have. So let me write another an. So we have 2an, which is 1 over n cos n pi over 2 plus 2 over pi n squared sine n pi over 2. So we have 2an. Now we need to find the bn. Let's see how you can find bn. If you could remember from the question, there was something given to us as this. Use a script t of x, 0 is equals to 0. What it means is that we should differentiate this one with respect to t. So if we differentiate this one with respect to t, this is what you are going to have. Use a script t will be equals to, now this is nx, so you will not touch it. It's this one that you are differentiating. If you differentiate this place with respect to t, you get 3n outside, and this cos will change to sine. But if you cos going sine become negative, so I'm going to have summation as n infinity, n equals 1 to infinity, negative 3n, then an here. Is that okay? Before you bring sine 3nt sine nx, sine nx. That one is for this side alone. Plus, let's move to this side. If I differentiate this one, the 3n will come out. This will give you 3n, then times the bn. Sine will give you cos 3nt. Is that okay? Multiply by sine nx. So this is what, after differentiation, you will get. Here too, that this thing was given to us as 0 is less than or equals to x less than or equals to pi. That was what was given to us. Here we are not using this one. Okay, it was given to us like this. This ut equals 0 means the f of x is 0. You have to know that. But before we even start that, ut is 0, so let me put 0 there. Summation n equals 1 to infinity. X is x, t is 0. So let's look here. If I put 0 here, that will be, the entire thing here becomes 0. So sine 0 is 0. So everything here will be 0. Is that okay? If I put 0 here, cos 0 will be 1. So the thing I'll be having 3n, this subscript n sine nx. So this is what I will have. This 0 here means f at x. So in case if I want to, this is Fourier sine. So normally you see we take bn equals, but now it's 3n bn. So we take the coefficient of the sine nx. So 3n bn is equals to 2 over pi, because the limit given to us was pi, 0 to pi. Now f of x is 0 here, then sine nx, and this will give you 0. If you integrate 0 times sine nx will be 0. Then if you integrate 0, you get 0. So everything is 0. It means that our bn is equals to 0. I hope you understand that. Our bn is equals to 0. So if our bn is equals to 0, it means if we come to this place, this one will go to 0 because bn is 0. So everything will go to 0, leaving final answer to be summation n equals 1 to infinity. Now our an is having two answers, so you write two of them together. So this is how it's going to look like. I don't even need to bring this, okay? If not, it will be some way. So let me write only the an. So the an alone is 4 over n pi squared sine n pi over 2 minus 2 over n cos n pi over 2. Then we also have 1 over n cos n pi over 2 plus 2 over pi n squared sine n pi over 2. So these are the two things. So if not that the an is giving us two solutions, we should have just substitute. Bn is 0, so everything here will be 0. An is this. So the whole of this is multiplying by cos 3nt sine nx. Thank you very much for watching. See you in the next video.